Okay. All right. Today, just a reminder, last time we talked about the conjugate rule. That was from the homework to page 43 stuff. Make sure that you know how to use a conjugate. That's when you're trying to rationalize the bottom of a fraction. One of the examples, I just erased off the board just a few seconds ago, was something like this. If this is your problem on like the test or quiz or whatever you have coming up at the end of the week, I'm thinking we're going to get to the end of the chapter by the end of the week, so as early as Friday we'll have our chapter test. If this is your problem that you have, like just remember, what you have to multiply by to rationalize the denominator, you have to multiply by the conjugate of the bottom. We talked about this on Friday. Make sure you know how to do that. You have to FOIL the bottom, distribute the top. We're going to talk about FOILing today. We're going to talk about distributing today because that's a big part of polynomials and binomials and trinomials. So we're going to discuss today. That's kind of our main goal. But again, when you're doing that, distribute the top. That means you're taking the top times both. Now, when you do that, make sure that you don't actually take the whole number times the radical. You just put it in front of it. Now, the reason why I picked this over here, a conjugate is where you change the middle sign. That's all you do. As you can see, I just changed the middle. The reason why you do that, it will cancel out the bottom where all the radicals cancel out because you're going to make everything perfect squares. Just because of the way that it works. We'll see that today. I'll kind of show you an example when we get to the products and stuff. Okay, questions on what a actual conjugate does and how to use it. Okay, that was what I think one of the middle problems, like 50 or 51, I think someone said last week. So just make sure that you kind of know how to do that. Now, let's move on. Let's talk about polynomials. We did that huge definition on Friday, big definition. I want to talk about the basic properties of polynomials, not just degree and stuff, but I'm talking about like how do you add them, how do you subtract, how do you multiply. Once we get to multiplying today, we're going to do a ton of examples. We're going to spend the most time today on products, how to multiply things together, because we still have to get to that problem that I showed you on Friday where they put a really big power on it. And I have to show you the shortcuts for that because you need to know how to do that. It makes the problems a lot easier if you know the shortcut for it. We are still going to do this today. We're still going to talk about degree and order because I don't think order I really even spent a second on it on Friday. There's this particular order I want your answers written in so it's easier to check and so that it's easier to do other types of work when we're going to get to those later sections. So we'll get to that. But the basic operations we're going to spend the most time on. But let's get started here. Let's just start with a very basic problem. 3x squared plus 7x minus 10. And we're going to add 4x squared plus 19. Okay, this is two polynomials being added together. It's a sum, right? How I know it's a sum, if you look at the two parentheses, you have a plus in between them. You're adding. You're not going to multiply in this problem. You are adding things together. Now, technically, when you add, you don't even need the parentheses. They're just showing that you have two different polynomials. But when you add, what do we have to add on this problem? When you first look at it.
The 4x squared and 3x squared.
Good. Why?
Because those are two common factors.
Common factors, like terms, whatever you want to call it. He's absolutely right. You have to add those together. When you add like terms, like these items in your polynomial, you have to look at the variable. They have to have the same power. That's what makes them like terms or common terms, whatever you want to call it. So the idea is that 3 plus 4, 7x squares. Okay, because you're adding the 3 and 4 together. Okay, now, the 7x, what does it add with?
Nothing.
Nothing. There's not a common term. So that 7x will stay by itself. Negative 10 and the 19.
9.
Not positive 9. This is your answer. That's a 9. All right. There's your answer. That's what I want to see. Now I know when you add and subtract, most people don't need to do anything. They don't need to write anything down. They can just kind of do it in their head. That's great. This is the type of answer I want to see on paper, like that. What you're looking at is called descending orders. Descending order. Greatest power down to smallest power, in order by x's. They always say descending order of x, right, or in x. That means you got to go the biggest power down. The terms here, the leading coefficients don't make the difference. I don't care if this had a 20 on it. The variable is what's the important thing. You look at the powers. If any terms are missing, like maybe there's an x missing in the middle, because they cancel out, it's not a big deal. You don't need to have it. You don't need to have every term. They just need to go big to small. The degree of this thing. degree. What's the highest power? 2. It's degree 2. Now, the reason why we need to know that, because I warned you later in the sections that we're going to get to when we're graphing like crazy polynomials, where I show you all the steps for graphing. The degree 2 means you have potentially for 2 roots for this problem. What roots are, it's how many x-intercepts you have. So if you were to draw this, potentially, this thing could cross the x-axis twice, because it's gonna loop around, so it could hit twice. It doesn't have to, but the degree means it has potential for 2 separate x-intercepts. That's what we're looking at. Questions, comments about this first one? Okay, I'm gonna leave that on the board. Let's do another one, but I'm gonna put subtraction in there, and we're gonna throw some more variables, so we can talk about that. All right, so subtraction. Let's go with 8x squared y plus 13y squared plus 5. And we're gonna subtract 2x squared y minus 7y. Yeah, we'll do that. Okay. Okay, kind of keeping it easy, trinomial, binomial kind of thing, but we're subtracting. Now I know on subtraction we talked about on Friday, it's a lot like adding, but you have to distribute. We're not going to multiply. Does everyone understand that? We're not multiplying. We're really going to distribute the negative sign, which I know in theory it's distributing a -1, so you're going to multiply by -1, but at no point are we going to FOIL everything together. That was a common mistake I saw from previous years. I'm at it, welcome back. But previous mistakes that people made was, thanks, that they would distribute the negative sign, they would leave the parentheses there, and then they would try to FOIL everything together. Big mistake, big mistake. So you just have to distribute, and then we'll get to our final answer. So when I do this, I just write everything down again, but I get rid of the parentheses. That way I'm not going to accidentally try to multiply things together. But I'm going to distribute the negative sign to the back. And so what happens when I do that? What do I get?
Negative 2x squared y plus
Good.
7y.
Good. All right, let's talk about that. Negative 2x squared y, because you had to distribute. And then on the second term, it became positive because it had a negative idea. That, some people will forget that. It's just a common mistake. People make that when they're distributing, they forget to change negative signs back to positives. That type of thing. All right, now we're going to combine like terms. This is the part that I always get questions on. I told you to put in descending order of x's, because I know a lot of people just write down the final answer after this step. Maybe you will do that. Let's do it on the fly. Which one do you put first? Really doesn't matter, because I don't have a lot of x's. There's kind of a mixed bag of variables. So in this case, I really don't care, like what order you put it in. Me personally, if I was writing this down, I'd probably put the x squared term first, just because I'm used to that. That's the biggest part of x. But then I'd put the y's and then the numbers in the back. It makes no difference how you want to do this. 8x squared y, can that combine with anything up here?
Negative 2x squared y.
Okay, so you're going to take 8 minus the 2, I get 6x squared y. Because again, 8 minus 2. Then, as I said, it really doesn't matter after that. I mean, because I've already combined these two terms, so those are good. There's no other y squared terms, so I'm just going to leave that 13y squared alone. There's a 7y by itself, and I have the 5. There's really nothing else because there's no like terms anymore. Just the first item's worth. Descending order doesn't make a difference anymore. There's just nothing to do there. It doesn't really matter the order you put it in. If there was only x's, yeah, I could see descending order. But for this, there's no purpose. Because these don't have x's, so they're just considered x to the 0, so they're all the same to me. Now, here's a question. What's the degree, though? Say it?
2.
No. Oh, that's a weird thing. It's not 2. Yeah, I just probably just crushed it there. It's not 2,
3.
sorry. It's 3. Let's talk about it. Why is it 3?
This is the
Oh.
x squared and then the y.
Yeah, it's x squared and the y. These combine, since they're all like together, it combines and you make degree of 3. And then the ones after is 2, and then there's 1, and there's a 0, if I'm going to look in order by the terms. So if there's multiple variables on one of the items, you actually have to add all the powers. I know that seems really weird, but even if there's more letters, you'd have to add up all the powers. And that's per item, so that's per monomial, and you can see which one has the biggest power. Now again, on a problem like this, we would not graph this. This would be a problem I would not ask you to graph, like later sections, because this has more than one variable and they're being multiplied together. That really affects the graph. Something like this, even with all my college and stuff, they would never ask you to graph something like this. They would just ask you to go like Desmos and just type it in and see what the graph looks like. Like there's no shortcuts for doing two variable problems like that. Questions at all about adding or subtracting? Or the degree? Okay, perfect. So we did all that stuff. We talked about degree. We talked about order, descending order. Sometimes the problems ask you to put in ascending, going from lowest power up to biggest power of x's. Usually that's always says in x. But the big thing I want to get to today is multiplying. Can we actually find products, like a small product, FOIL together? Or can we do a larger product where you do like trinomials? I want to talk about the shortcuts for how you know like how many items you're going to have. Okay? Does anyone still need these two problems? I think they're pretty straightforward, right? Okay, let's get to problems. Let's get to multiplying. We'll start small, we'll work our way to the big, and then we'll get to the stuff I want to discuss and why that conjugate problem kind of applied, and why I waited to tell you about the conjugate until Friday. All right. Let's go with... trinomial, right? 3 items and then on the inside I can't add them together. I'm going to FOIL this with 5x plus 4. Now I said FOIL, it's really just distribution. It doesn't matter the order you write your parentheses, you can actually switch the parentheses around, it makes no difference to me. But when you have a problem like this in your homework, eventually, not today, but eventually this week when you have homework, the big thing I want you to know is how many items you'll have when you write it all out and what it should hopefully simplify into, what you should have. On this particular problem, how I think of this problem before I even start, I think of like the actual size of the polynomial. So like I said, this is a trinomial, right? There's 3 items in there, there's 3 items. This thing is a binomial, it has 2 items, binomial. And when you multiply these together, you should have 6 items across, 3 times 2. That's how I think of it. So I know there's going to be 6 items altogether. Now, should it simplify? Yeah, it should. The reason why I know it should simplify is that I have similar variables and non-variables in both parentheses. When they share like terms like that, it's almost guaranteed it will simplify in the end. There shouldn't be 6 items all the way across. If there's any change in variable from this polynomial over to here, if there's any change in variables, then it probably won't simplify. It'll be 6 items, and that's probably where it will stop. So just, that's my little like tip for you if you want to know like is it going to go down. It should, since they share similar items, x's and just numbers. But to FOIL, let's get rid of this, or distribute, it doesn't matter like what size of polynomials you have. I always do the same rule that whatever parenthesis you have written first, I go to the second parenthesis. If there's more than one parenthesis, just go kind of 2 at a time, so 2 parentheses times each other. And what I always do is I always just take the first item, take it times everything in the back. So that'll be 2 items separated. And then once those are done, then I'll go to the next item and take that times everything in the back. And then the last item times everything in the back. Like that. So that's how you're going to get your 6 items. You can see that I'm color coding as I go. Just remember that when you do this, it's still law of exponents. That's what it is. You're just multiplying items together. You can add the powers. It's all the same stuff you learned since Algebra 1 or Algebra 2. I don't know when you first learned this. But let's do the items here first. X squared times a 5x. 5x cubed. Here's why. This is a 1 times 5, so you know you're going to get 5. And then the variables, since I don't know what they are, you just add them up, because you can't multiply those anyway. So that was 1x squared times 5x. Now 1x squared times 4. 4x squared, yep. So there's your first 2 items, color coded. So that's the 1x squared times everything in the back. So now I'm going to do the second item. We'll go in blue now. 2x times 5x. 10x squared, yep. Because it's 2 times 5, which is 10, and then the variable's just thrown in the back. You just add them together. You just can't do anything with it. And now 2x times 4, 8x. Okay, there's your next two items, right? That's the middle two. And then the last items are the 1 times the 5x, which is what, 5x? And then the 1 times the 4. There's the last two. And as you can see, as you look at this problem, it does simplify. They shared variables from the first parenthesis to the back parenthesis, so it will simplify. It's almost a guarantee that when they share items, it will work. So final answer here, if I keep going, it looks like 5x cubed is by itself. 4x squared, 10x squared is 14x squares. 8 and 5 make 13. And the 4, there's your final answer. That's in descending order. What's the degree of it? Degree 3. So in theory, if we were to draw this, which we will eventually do in later sections, allow us to draw this type of polynomial, I'll show you the shortcuts for it. There's little rules. Potentially this thing could hit the x-axis 3 times. Because the graph, traditional like cube graphs look something like this. That's what cube graphs look like. Sometimes they're stretched out to be more like this, where they kind of flatten out. But traditionally there is a change in direction, so it could potentially hit 3 times. That's why the degree is 3. It could hit the x-axis. There could be 3 roots. Just depends on what they're, since there's more than, a few variables, I'm almost expecting it will kind of go up and down kind of thing. Those are things we're going to learn in, I think it's like the first chapter. It's like the first section we start graphing. And we learn throughout the chapter 1 how to graph like crazy stuff and all the little rules every single section. Okay, we're good with that first one? Okay, that basically taught you the rules. So if you had, binomials, same thing. If you had, a polynomial, like 4 items and a 3 items, same thing, you just distribute them all. The one I want to get to today is to do powers, right? Something like this. We're going to start small and work our way to big. All right, so if you have a square, I don't want you to distribute the square. That's a common mistake people make. They look and go, oh, I can just put the 2 on each item, we're good. That's if you had a single item in the parentheses. There is a binomial on the inside, correct? If it's a binomial or bigger, you cannot distribute the power. So what I look for is plus and minus signs, basically. But once you have this, you can, since the power is relatively small, I would just do it by hand, right? I would write out 2 parentheses and go through the math here. So what I mean by 2, this is the definition of an exponent, means you have 2 of them, so 3x plus 6 and 3x plus 6. And you're going to FOIL like we did over here. First, outer, and last, or distribute twice, however you want to think of it. But it's not meant to be like a difficult problem, not until we raise the powers up bigger. So we're going to multiply the 3x times everything in the back, like I did earlier. So 3x times 3x is 9x squared. 3x times 6 is 18x's. So that's the first item times everything. Now the back item is 6 times everything. That's 6 times 3, that's 18. And 6 times 6 is 36. And just like I said earlier, if they're sharing similar items, which they are, the first parenthesis, the second parenthesis are sharing similar letters and numbers, and not just the digit value, but they're sharing the same like variable type or non-variable, like terms, it will simplify. So it's not going to be left with 4 items. That's how I know it was 4 items across. It was 2 times 2. So there's going to be 4 items, but it should simplify down to something smaller. But again, actually adding these together, I get what, 36x plus 36. There you go. So it's degree 2. We can eventually graph it parabola. Okay. Questions at all about simple powers, like what that means? Okay. Now I said this is the easy problem. I'm going to show you the rules for how there's this chart. It's called Pascal's triangle. And Pascal's triangle is a simple way for how you can FOIL or distribute more than just one parenthesis together. Okay? That's what we're going to learn. I'm gonna put the chart on the board. I'd like you to write this chart down somewhere in your notes. I'm not gonna go too far. I might just go like 3 or 4 lines on this chart. I'll explain how it works here. And then we're gonna apply it to this problem right here, this problem, so you can see the answer. Now, on this problem, I already kind of warned you, if it had simple numbers like a power 2, I would not use Pascal's triangle. I would use it for like maybe 4s or bigger. But I want to show you that it does work and how to do it. And this is important that you learn this, because I know like on the test, I'll have a problem where there's a pretty big power, you know, something like 7 or above. And so you have to use Pascal's triangle. You wouldn't have enough time in the class to get into the test unless you knew how to use it. So here's the chart I like you to write. Okay, I'll let you write that down, and this thing will keep going, but I'll explain. So let's write this down. This is the triangle that we need. Again, it's called Pascal's triangle. It's used for how to FOIL items together, like this. It's usually reserved for binomials. That's what we use it for. There is a way that you can adapt a trinomial to it, which I can kind of show you later, but yeah. Okay, I know you're still writing the triangle down. Every time you go down a row, it'll add another number to the list, so it is making it almost a perfect triangle. How I made the list, so it's not something magical how I did it. The outsides are always 1s, so for top is a 1, and you have 2 1s, and then you have a couple numbers. Now how it works is anytime you go down to the next rung, you know the outsides are going to be 1s, and it should have 3 numbers. You know, so this one had 2, so it should have 3. How I think of this is that you just add these 2 together to make this number. So when I went down to the next row, there should be 4 numbers now, and the 1s are on the outsides. You add these 2 numbers together to make that one. Add these 2 together to make that one, there should be a 1 on the outside. And you can see the pattern does work. Yeah, makes sense? Like how you, so it's not something like, it's not crazy how you can memorize it. You can kind of make it on the fly. Okay, what this is any time you have a polynomial, like particularly a binomial, and it has a degree of this value. So degree 0, degree 1, degree 2, degree 3, degree 4, degree 5. So anytime you raise the power on the parenthesis, that's what I'm looking at, okay? This will help you get to your answer, this little triangle. It doesn't necessarily tell you the answer every time. It helps you get there. All right, so let me explain. So, as you do this, these numbers are going to be what you're going to use as basically kind of like leading coefficients. So in front of your terms, there will be, a 1, or there'll be 2 1s, or there'll be a 1, a 2, and a 1. So you can kind of see like what the answers will be. This is giving you basically your final answer for when you raise a parenthesis to a certain power, how many items should be left. Like in this, so if I put something to the degree of 0, you're going to have 1 item just right now. There won't be 2. It doesn't matter the parentheses. So if I had that parenthesis, 3x plus 6, and I put it to the 0 power, there should just be 1 number left here. 1 number. And the leading coefficient is going to be the number 1 in front of it. That's basically what it's kind of saying. Well, what's anything to the 0 power? 1. It's actually correct. It's actually telling you that your leading coefficients can be 1. It's actually 1. The answer is actually 1. Now, when you put it to the power of 1, so you raise the power, so now we're going to put a 1 here. What's going to happen is that your leading coefficients are going to be 1s. So you're going to have 2 items now written out, and they're going to have 1s in front of them. Now, this is where it gets tricky. This is the part we need to practice today, so you're not like overwhelmed by this. This is your first time seeing this. It's actually easier to see if I show you the later steps. But how this works is if you put anything to the 1 power, now everyone knows anything to the 1 is just itself, right? But what you do is that whatever this item is, you put it in descending order. The x's are going to go down in powers, like that. Okay, x's are going to go down in powers. And then your numbers here are going to go down in powers as well. So it's going to count up. So it's going to go like 3 to the 1, 6 to the 1. So they would count up and down. Okay, and I think what's the best way I can show you this? All right, so here's how I've learned it. You'd actually take both items times each other in this parenthesis, and it makes every item going down. Let me explain. Now this will make a lot more sense when we get to the bigger items. So there is going to be 2 items. We already know this answer is going to be 3 plus x, or sorry, 3x plus 6. We already know that. But how I think of this is I look at the chart. I know there's going to be 2 items. So it's going to be a 1 and a 1. And what happens is that you use the items in the parenthesis, in this parenthesis, and what's going to happen is that every item in here is actually going to multiply on itself, and one's going to count up in power, one's going to count down in power. What do I mean by that? This is a binomial, right? I'm going to start with 3 to the x. I'm going to put a 1 on it. Okay? The other item is going to start at 0 and count up. Now, how I know that? So the 6 is going to start at 0 power. Because one of the items will count down, one of the items will count up as you go across. I know that seems like really difficult to hear for the first time because you haven't seen it yet. But each item in here makes every single thing across. And how I know what power to put on these is whatever the degree is here. So if this was like a 2, I'll put a 2 here, a 0 here, and then they're going to start counting, and I'll show you that here in a little bit. And so the next term down, I use this leading number here. So I'm using the second one because I said there's 2 answers, and they're being separated by a plus sign every single time. And so let's move this thing over. And so the next item, this item here is behind the second one, because like I said the second number has a leading coefficient 1. This item is going to count down in power, so it's going to go 3x to the 0, right? It's counting down in powers. This item will count up in powers, 6 to the 1. That's how it always works. Doesn't matter what the powers are, if it's a 2's, if it's a 4 outside the parenthesis, but they count down and 1 counts up every single time. Does that somewhat make sense now? We'll do more. Okay, and as you do this, it will give you your final answer. Now I know this is stupid, we already know the answer to this thing, it's right here. But this will actually prove it. What's 6 to the 0? 1. What's 3x to the first power? 3x times 1. Well, that just turns out to be 3x. Okay. What's that's 1. What's 3x to the 0? 1. What's 6 to the 1? 6. 6 times 1 times 1 is 6. There's your answer. You're like, well, Ward, that's stupid. I already knew it, right? Anything to the 1 is that. But you're going to start to see how this can like radically change your idea of like this problem. Because if I raise the powers, I'm going to go to 2 next, and then I'm going to go right to 4 or 5. I'm going to just jump. So you can actually see the process here. So, the problem I just did a little bit ago. I did a power of 2, correct? Is that the second one I did? Was it 3x plus 6 still? Is that what the thing was? All right. 3x plus 6. And this was squared. Now, we already knew the answer. It was 9x squared plus 36x's plus 36. Okay, that was the answer we were looking at earlier. But let's show you how this process, like how this Pascal's triangle, actually gives you that by following that rule I just showed you. So you can see this. Okay, so what power is it on that parenthesis? Power of 2, right? It's degree 2. That's on this parenthesis here. Again, we're going to try to show you that this is the answer using a different strategy. Now I know this is kind of easy when you do it. But it's got a degree of 2. So we got to find the degree 2 on my Pascal's triangle. This triangle says there's going to be 3 answers across, which there is, right? We already know that. There's going to be 3 answers. This is telling me these are the leading numbers out front. So it's a 1, a 2, and a 1. So if you want to write those down, separate them. So we're going to do this by the Pascal's triangle. 1, a 2, and a 1. there's actually 3 items written. Okay? So that's where my numbers come from Pascal's triangle. Everyone understand the first part, how I use the triangle. Okay, now let's keep going. So as I said, you have 2 items in here. The items are going to count, one's going to count down in power, one's going to count up in power. So the 2 items, I'm going to always write them down. So I'm going to have the 3x and the 6 on every single one. Those are my 2 parts. They're going to be on every single item. But one will count down in power, one will count up in power as I go. And how I know this, how I know how to put it, is you look at the power that's on the parenthesis. What's my power on the parenthesis? 2. So the first item will start with 2, the second item will start with 0. And as you go to the next item, this will count down, this one will count up. That's how it's going to work every single time, okay? So the next item, so this is a 2 and a 0, right? The next item, 3x, will now become a 1 power, because it's counting down. This item will count up in power, so the 6 will become a 1. See how that works? One's counting down, one's counting up in power. So now we go to the last item. This one's counting down in power, so now what will be the next 3x be for power? 0, because it's counting down. And the 6 is counting up, so what will be the power on the 6? 2. And what will happen is it will make your final answer in the end if we do all this math. So what's 3x squared? 9x squared, because you can actually distribute the power, right? What's 6 to the 0? 1. There's your first item, which we already know, 9x squared times 1 times 1, that's a 9x squared. Okay? Next item, what's a 3x to the first power? 3x. What's a 6 to the first power? 6. So if I multiply 2 times 3, that's 6 times 6, that would be 36x's. So far so good. Next item, what's 3x to the 0 power? 1. What's 6 to the second power? 36. 36 times 1 times 1 is a 36. And there's your answer right there. 3 items across, it works. As I warned you, when you first see it, it's just like mind-numbing. It's like, oh my god, that's impossible to learn. But once you see it for like the 5th power or the 7th power, then it starts to click. You can actually see the pattern that you have to do every single time. And once you see it for the bigger ones, it makes total sense. It makes, I guess it's hard to see like how this is always giving you the answer, but it'll make sense when you see the pattern and how you're supposed to write it, how you get to your answer every single time. It makes problems a lot simpler, okay? So we're gonna do the same problem, 3x plus 6. We're gonna put it to the 8th power. 8th power, okay? And we're gonna, now to check this answer, I don't wanna do it by hand. I don't have enough time. I have 3 minutes left of class, okay? What I wanna do is we're gonna, you'll need Chromebooks tomorrow. We're gonna bring your Chromebook and I'm gonna show you a website. We're gonna type in the problem and it'll do it for us. So we can actually see like, it'll do it all rigorous all the way out and write all the terms, but it'll show you some fine answer as well. Make sense? Well, let's start with writing down. If the bell goes off, we'll continue the problem tomorrow, correct? Okay, all right, here we go. Let's do the 8th power. Actually, let's go 5th. Let's go 5th. I only have 5 steps up here. I'll have more up there tomorrow. Well, let's do the 5th power. Again, I'm expecting the bell's gonna go off here pretty shortly. Like 3 minutes left. All right, we're gonna go 5th power. So 5th power is this rung right here. So by looking at this, I'm gonna have 6 items across the board. That's what that Pascal's triangle is telling me. So I know I'm gonna have a 1, a 5, a 10, another 10, another 5, and a 1. And these are all being added together. Okay? One of the items will count down in power, one's going to count up in power every single time. And again, where I got the 1, 5, 10, 10, it's from right here on that 5th rung of the Pascal's triangle. So if we could put it to power 5. So we're going to have, on each of these, we're going to have 3x, and each of these, we're going to have a 6, because that's the 2 parts of the binomial that's in that parenthesis above. So you need to put every parenthesis. each item affects the final answer. So every single item will have a 3x, every single item will have a 6. Now, what's the biggest power in the parenthesis out on the outside? What's the biggest power here? 5. So the first item will have a 5, and then the second item will have a 0. One will count down, one will count up. That's how it works every single time. So the next item will have a 4, this one will have a 1. Then it will go 3 and 2, 2 and 3, 1 and 4, 0 and 5. One counts up, one counts down. When we type this in, we'll get to our final answer. Does everyone see how the power system works? The 3x's are counting down, the 6's are counting up in power. 3 to the 5th is a pretty big number. 81 times another 3. I think it's bigger than that, isn't it? Right? Wait, 9, 81, yeah, you might be right, 243.
We did my work so much.
243. No, I think you're right. I think it's 243. All right. This is a 1. That's a 1 times 243, 3 to the 5th. All right. 3 to the 4th, that's 81 times 5. 81 times 5 is 405 or something like that. And we take times 6. 2043? 2,403? I don't know. Somebody do it. Somebody have a calculator, please. 3 to the 4th power
81.
times 6 times 5.
430.
Okay. And now 3 to the 3rd is 27. We'll take 27 times 10, 270, times 36. Oh, I can't do that in my head. 270 times 36.
9,720.
And this would be x to the 3rd. And again, that's 36, that's a 27, that was a 10 because of the powers. And as you can see, we're going to keep going here. Now I know the bell's about to go off. We're going to finish this tomorrow. And I know that you're looking at this going, God, this is insane. It's a lot easier to do this than write out 5 parentheses and foil it all out. Okay? We have about 30 seconds left here. Try to get packed up. If you have not turned in your page 43, get it in. I need it in today. Get it in. Okay? All right. There you go. We'll come back to this one tomorrow. Somebody needs to have this problem written down if you have not already.
Sure.
Yeah.
On this one, Sam Jordan was the same answer and they got it right.
Okay. Maybe I just made a mistake. Put it back in my head. Maybe I just made a mistake on that.
If I got a couple wrong, can I fix it?
Yeah.